Welcome to another video. In this video, I will show you simple explanation. Some simple explanation about vector and how it's used in physics. So, what is vector? Recall that in previous video, I told you about position, velocity, acceleration, and its higher order of derivative with respect to time parameter or variable, which is those three or the higher order itself mentioned as a vector. Now we look at position vector. For position vector, we got information as well as where the point inside the space. Of course that this information may contain not only one single number but maybe array or collection of number as x, y, z component in this coordinate system. Next one is velocity vector, which tell us rate of change again of position vector, which is known before as displacement in previous video. And by some intuition, we know that we get information as how significant displacement in magnitude, which for each x, y, and z component that may be independently each other, which is differently totally each other, or related sum rule, which is depend each other by law of physics. So which is every direction maybe has different displacement from the others and etc. I will place this title need three array of numbers too because each axis has three different, which is in Cartesian coordinate, of course, maybe with different value, maybe depend each other or independent each other by some function of time, and so on and so on. And fun fact, notice that direction of vector may be depend on time. So in geometry and some physical means, vector can be drawn by some kind of arrow like this, which its tip point on some point in space. We can recall to the position. For position vector, this arrow at the tip, of course, tell you the position or tell you where the object is in the space. So, by that geometrical interpretation or geometrical means, we can generalize vector with some mathematics. As first, vector has commutative and associative in addition, which is explain how vector can be added as position. Commutative is v plus w vector, it's equals to w vector first plus v vector first, v vector at second. So the associative is gone because of commutative. So we can add v and w first, then add it by x, or w and x first, and then v and so on, so on, so on. The next one, we has zero vector with length or its magnitude is zero or just point light in geometrical interpretation. The next one is a scalar scaling. I mean, each component of vector is a number. So if I multiply it by just a scalar or just a number, we scale each component. So it's usually number, okay? So that means we can scale it into zero or negative. So vector can be negative or zero. So the subtraction, it means inverse addition as usual. And fun fact, this rule drives us to gently understand about linear algebra in physics, especially abstract axiom of vector space. The next one, we have some important things you need to know. The first one is about linear combination, which is tell you that our vector as a position, we can decompose this vector into 2, 3, 4, and etc. vector by addition. So that we call it linear combination, which is every vector maybe can be built by other vector as a linear combination. The next one is linear independence. Linear independence means if R as before as a position vector is zero vector, which is has zero length vector, and x equal y equals z is equals as a zero vector, then x, y, and z vector are linear independent each other. So that means simply that you can create a vector with other vector that has linear independence. Linear means addition, so yeah, that's what I means. Okay, the next one is a span, which is collection of some vector in that vector space we recognized as before that can build another vector in entire of vector space. So I have a few vector and then I can make any linear combination by scalar multiplication or some combination by linear combination as before. So I can build every vector in the vector space. Okay, now we have a basis of a vector space. Basis is a span, but as minimum collection as possible. So span with the smallest number of collection of a vector, we call it a basis, which means basis is related to dimension. This is very fundamental abstraction in linear algebra you need to know before we continue to more and more about vector. Or for this thing I just write is as a basic linear algebra for physics. But for now I will stop this video and continue to some example in kinematics again with the special things I will can gently drive you guys to understand about calculus as previous video and about the vector to explain how kinematics, how physics, and maybe how universe works by physics law. I think that's it. Don't forget to share and subscribe and see you later.